All right, everybody, welcome to the Project Phasor governance meeting. We've had a lot of technical discussion and gathered a lot of interested parties interested in collaborating in this area. But there's a lot of questions about how do we handle governance, what areas make sense to work on versus duplicating potentially. And we have a bunch of special guests today. Folks from the Edge AI Foundation. We have Petruț Bogdan here, and then VJ Reddy will also be joining the second half. From Khronos, we have Neil Trevett. From the Open Compute Project, we have Harwood and Jascha Achterberg. And for ML Commons, David Cantor had to cancel last minute, but he might be able to call in. I also tried to find substitutes, Peter Matson and Miro Hodak, but I didn't hear back from them, but maybe they'll join too. We'll see. For the folks that are on the call right now, do you guys want to go ahead and introduce yourselves, your background?
Do I jump in at this point since since you put me first, or?
Yeah, we'll just go in the order then.
Okay, so I'm Petruț Bogdan. I generally go by Peter. I'm a neuromorphic architect at Inatera Nanosystems. We make semiconductors. We sell chips for Edge AI, for TinyML, that are brain inspired. These are MCUs with a few accelerators built in for doing signal processing. So we are very much in on the neuromorphic approach. And as part of the Edge AI Foundation, I'm co-chairing a neuromorphic working group focused on neuromorphic computing with my co-chair, Professor Charlotte Frankel from the Technical University in Delft. And we're bringing in people and different neuromorphic communities to try and make a more streamlined and more consistent ecosystem for neuromorphics, to make sure that benchmarks exist and that we are rehousing a few different open source initiatives that would need some funding or resources or direction. So within the Edge AI Foundation, the Edge AI Foundation has a lot of different partners, industrial partners that can offer, for example, use cases and directions for neuromorphics. In short, I'll keep it here, stop it here.
Right, then Neil.
Yeah, hi everyone. So my name's Neil Trevett. So my day job's in NVIDIA, but I'm here with my Khronos hat on. I work some in AI. I'm not a deep expert in the domain here, but mainly here to help if I can on the discussions around some of the pros and cons around different types of governance.
Thank you. Then Jack.
Yeah, I'm Jack Harwood. I co-lead a group in OCP around AI hardware software co-design, and we have taken on 2 projects this year for us to build POC. One of them is HPC AI large-scale fabrics modeling, system modeling, and simulation. And working on how large-scale ecosystems work. And the other part, which I've been talking to Jascha about, and he'll talk about, is are there ways that we could start to look at things much more Edge AI focused? So as we start to look at large-scale building models versus inference in kind of the ecosystem, and can we do some elements around what are the characteristics? What workloads, what algorithms, what characteristics, and then can we actually model, simulate? And prove out some of those elements as we start to look at things around agentic AI, Edge AI, and what is kind of that hardware, software, co-design space as we start to publish documentation, work across OCP, and then essentially across larger groups.
Awesome. And Jascha.
Cool. Yeah, my name is Jascha Achterberg. I'm an academic, so I'm at the University of Oxford, where I'm a fellow. And Yeah, so I recently joined Jack's open compute efforts, essentially bringing in the algorithm side to the already ongoing hardware simulation side, essentially. And I'm very interested on the idea of how we can make large scalable heterogeneous compute systems work. I'm coming from the kind of neuro-inspired side. Actually, I know Brian from Intel days. And yeah, my perspective on this is a bit of like the brain is a large distributed systems of very heterogeneous regions. How can we learn how the brain does it and bring it into silicon technology and, you know, making this interchange working in both directions, really.
Great. I don't think anyone from ML Commons has joined, but VJ is also involved in ML Commons. So maybe he can, once he joins in the later half, we can have him talk about it. But just to, you know, a quick overview of like potential areas of collaboration. You know, some, you know, which we focused on in Project Phasor as potential areas, but there's a bunch of other ones that have kind of come up as things that people are interested in working on. One of the first things is collaborating on higher level neuromorphic training algorithms. There's a lot of things that have developments recently, both that are, you know, targeting production, and then also at the other end, much more research focused. You know, things that are focused on production, things like sigma delta networks, and then things that are more researchy, you know, are much more like neuro AI inspired. And there were actually a lot more people interested in working at this level, even though I was trying to pitch Project Phasor as more like of a compiler effort. It seems like folks like Inatera, Spin Cloud, and Gray Matter Labs at Snap would be more interested in working at this level, it sounded like. And then there's also some companies like Cambria who have, you know, algorithms that they want to keep a trade secret, but where they want to share, you know, workloads at like a benchmark level. And, you know, there's existing efforts like Neurobench and things like that, that we could potentially collaborate with there. And then there's intermediate representations, like there's Near. I don't know if the folks working on Near are here right now. I think they have an overlapping meeting. But there's a bunch of frameworks, neuromorphic frameworks that all can convert to the near intermediate representation already. And there's a lot of interest in making that more robust and you know, creating like a model zoo and things like that they're talking about right now. The one thing I was really interested in was creating a shared neuromorphic compiler. And I think this is something that would really benefit the research community. But, you know, if we could also find ways to overlap with folks in industry. I know Synsense is interested in, you know, donating their code base as a potential starting point for Project Phasor and a compiler effort. Their stack includes simulator, behavioral simulator, and I think they also have a gate level one, but that's more internal. But yeah, I think this would really enable neuromorphic architecture search, which is another area I'm super interested in. That's definitely more researchy, but there's such a rich area to explore here. I think especially around heterogeneous compute, like how do you combine digital neuromorphic and analog neuromorphic to combine the best pros of each. And I think there's so much to explore there. The other thing that I think a lot of folks are interested in is heterogeneous integration at all levels. CPUs and GPUs are going to be good at what they do, and then Neuromorphic is going to be good at what it does with sparse networks and things like that. How do we combine the two? At what level does it make sense to combine the two? Another area is, establishing a joint research fund. I guess we want to talk about funding in general, how that works. But it'd be interesting if we could form a fund that supports research in this area, algorithms research that targets hardware realistically, potentially targeting the neuromorphic virtual machines that we could come up with, where we provide accurate estimates of power usage, so that the algorithms researchers can't really make outrageous claims about how much they improve overall power. Then something that I feel like is missing in the ecosystem is targeting data center scale training. There is SpinCloud and Spinnaker, which do address this area, but I feel like, especially at the production level, a lot of the focus is on inference. And then some folks brought up, neuromorphic data sets and enabling simulated worlds to support neuromorphic sensors and things like that. I don't know if there's other areas that people want to bring up, but I feel like I try to incorporate everything that people have brought up broadly. So yeah, I think maybe we can, with that context in mind, I don't know if we want to go through and with the invited speakers again, and if they could talk about their organization and how it might, whatever comes to their mind about how things might fit in their organization, or generally about governance, what needs governance, what doesn't need governance, things like that.
Hi, this is Jack. So in terms of some things that we've been discussing in the work group for us to build a project, as I said, we've been looking kind of large scale. We've kind of bifurcated a bit, but we're trying to work on kind of the same principles of what are some of the baselines, the fundamentals, the foundations that we would look at any given ecosystem. So if we look at, for example, like on a chip level, for hardware, software, co-design, or what I've been talking about with Jascha is like more of an interconnected set of chips that may allow us to do edge inference, things like that, nodes connected on a frontier. What does it mean for us to do kind of the hardware software space, but also from a hardware space, what sort of characteristics do we need? And how would we actually define those characteristics, map them to workloads, algorithms, and then from there be able to simulate, model, to vet out kind of those characteristics. We're not going to be able to build hardware by end of year, but we'd be able to look and say, hey, for us to be able to do these kinds of ecosystems, hardware design, running this software, here's the characteristics, and here's kind of the model that would be able to at least show some fundamentals of that. So if I look at kind of provide solutions for heterogeneous integration. One of the things we've been looking at is if you start to look at least from a chip level or from kind of a sea of chips, we have CPUs and then we have offload engines, kinds of things, and how could they cooperate? What kinds of things we could go through and do? What is the topology, fabric, things like that. So we're trying to focus very much on kind of fabric topology centric kinds of things and where we would put some of these heterogeneous engines to run workloads. So target data center scaling training. We're working on that as part of the other piece. Today we have HPC and what would look like AI pieces. And so we, from a workload point of view, if there was something that we would need to go off and do, we have a modeling tool that we're going to bend a bit to fit into some of these things we're going to try in terms of traces, driving some pieces, building modules, doing things like that. So we have a couple of places that we're going to overlap, and we could, as we start to put pen to paper over the next 4 weeks, to be pretty definitive about what we're doing, what the goals are, where some of these things are. We're more than willing to share and evangelize through this team as well as the team on the OCP side. Did that make sense?
Yeah.
Okay.
Well, that was good, Jack. Do you want to go, Brian? Are we going in order?
However, Neil, if you want to talk, I know Khronos, you guys had a a compiler effort recently.
Yeah. Do you want to? I don't think I can share. I promise I won't spend more minutes on PowerPoint, but do you want to bring up the slides, because it'll provide some structure maybe too, because we did put some thought into.
Oh, it's in the chat.
Yeah. Did you see it? I can repost it again.
A minute. Okay.
So, first of all, no, thank you to Brian, and I had the chance to speak to Brian to figure out how we could best contribute to this conversation. We're very happy to be part of the conversation. I don't think Khronos is necessarily the right place, but we're just happy to help because this is a worthy effort. So this was just our thoughts, and again, I promise to be quick. If you go to the second slide. Just as context, if you haven't come across Khronos before, we are a standards organization. Our focus is on low-level APIs, compilers, and file formats for offload acceleration for things like 3D, XR, AI. We are active in AI. So we have a bunch of members. We've been going for around 20 years or so. Slide 3. The key thing. So we're just trying to think, what would we be thinking about if we were trying to do something similar and figuring out governance? The first one is to get clarity on the difference between open source and open standards. It's surprising to me how often folks get confused. So of course, I'm sure people here are aware open standards are where you have a specification together with conformance tests, and importantly, particularly if it's hardware related, an IPR framework, so you get appropriate patent licensing. But the whole point of a specification, an open standard specification, is you can have multiple implementations. So in a hardware space, this can make perfect sense. I mean, it would be a boring world if we only had one kind of a GPU architecture. You know, in some domains, vibrant commercial competition is great, and that's why you need an open standard, so you can get interoperability without forcing everyone to a single implementation. On the other hand, open source is also where you don't need multiple implementations of something. And very often it's a language compiler, to Brian's point earlier. And then open source, of course, lets you share the implementation load. And that can be awesome. And it can also prevent fragmentation in the most simplest way. But everyone uses the same piece of software, so that's guaranteed no fragmentation. So, but it's important to know which. And often an organization will use both, but typically an organization will have primary focus will be one way or the other. So that's kind of one point. And so the next slide I'll do super quick. Khronos kind of came from the 3D. We've grown into compute and AI over the years, but the 3D was where we started. And just kind of to note, because often if you're in the standards domain, you often hear, oh, standards, they force everyone to a lowest common denominator and you can't innovate because standards are way too slow. I hear it all the time, but I think, the GPU domain is actually an exemplar where you have an extensible API that gives you velocity, and you have a well abstracted API that only dictates functionality. It does not dictate implementation details. You can get fast moving, you can get lots of healthy competition, and you can grow a market really entirely based around open standards, or at least largely based around open standards. And the GPUs is an example of that. So I think for neuromorphic computing, it's great. You guys are thinking around this early. Just a quick parenthesis, Mesa, which is an open source organization active in graphics, they have an internal IR called NEAR. So you may want to avoid a namespace clash. I'll put the link in there if that's of interest. I just noted it going through some of your slideware. Next slide. So Brian did share with me, the organizations that we're talking with, and that all the organizations here are awesome. And it's actually very interesting that we're all doing slightly different things, which is, I think, interesting. I've kind of put the organizations in order. The Unitary Foundation is early stage ecosystem research and cooperation, going through building use cases, which is something that the Edge AI Foundation does, then building open source tooling, which is of course something the Eclipse Foundation is super skilled at. Eventually, but probably not yet, you might want to do some standards, and organizations like Khronos do that. And then you have organizations like Open Compute that are really figuring out how to get things deployed at commercial scale. And then last but not least, once everyone's deploying, you might want to start doing commercial benchmarks. So there's a kind of a timeline here. And it's cool, actually, that all these organizations are out there and are all contributing to different things. Khronos is a standards organization. So if you go to the next slide, the key thing about standards is don't do it too soon, and don't do it too late. But I think for neuromorphic computing, I think too soon is the danger at this stage. Don't do R&D by standards committee. It's death by 1,000 cuts. We've tried it before we realized what we were doing. If it's not already kind of obvious what it is you want to standardize, it's too early. It's too early to standardize. You should let the Darwinian soup ferment a little longer. Only when people are getting really frustrated, the fact that through lack of standardizations, it's obviously has become a pain point or a friction point in the industry, that's the right time to standardize. And I suggest we're probably not there yet for this domain. So I wouldn't standardize yet. You don't want to wait too long, though, because then you miss your window, and it can be hard to reconcile once multiple proprietary technologies get embedded. And then slide 7, probably my last slide. Maybe how am I doing on time? I'll speed up. So I actually this is my best slide. I was trying to think, well, where is this group in this kind of timeline? I think you're kind of around stage 1. I would suggest trying to model something around what the Unitary Foundation are doing. I mean, they're doing really awesome work, but collaborative, cooperative research and experimentation seems to be my desk research seems to be kind of probably the right thing to focus in on at this point. But wherever you come in on this pipeline, 2 key things: you must have open governance. If it's an open source project, or you're trying to build a standard, or you're trying to do some other kind of collaborative work, it's key that no one company has control, because you won't get industry trust. It doesn't matter who the company is. If you're trying to build a collaborative effort, it needs to be under collaborative governance. Also provides resilience. If you put over dependence on any one organization when commercial quarterly results come and go, you need to have resilience with multiple stakeholders. And of course, you don't have to do this all by yourself. There's a whole bunch of organizations, some of which are on the screen here, that will be more than willing to help. Patent licensing could be the thing that can be tricky to take between organizations. So it's the patent licensing. Maybe I have my standards hat on too much, but that's something to be considered. And then maybe just switch, because you did mention the compiler, Brian, so switch to the last slide, 9, and I'll shut up. That slide 8 is just talking. Khronos has a process. Anyone can suggest a new thing at Khronos, but I think it's too early for that. But slide 9, We do have an open source compiler. It's not for neuromorphics. It's a shading language, and it's in open source, which is awesome. So and it's under Apache 2, so you get all the contributions to license for use, and it's permissive, and hopefully, but we're getting good success in building the community. If, though, the compiler is closely associated with hardware, which I think probably will be the case here over time, it's important not to forget patent licensing for the specification of the language. If you end up with a language compiler, it's not just the open source implementation necessarily, it's the hardware implementations underneath the compiler may need some patent licensing coverage. And if you want to have, in the longer term, multiple implementations of that compiler, you need patent licensing around the spec, not the open source. And the way there's a few standards organizations trying to figure this out. The way that we've done it at Khronos is we take snapshots of the language spec, which is primarily an open source, and we ratify it under our IPR framework in parallel, and that generates patent licensing coverage. But probably too much detail at this point, but happy to go into more detail if we need.
On the topic of patents, does that mean Khronos owns the patents? Or
no. And that's another misconception, that patents are evil in the standardization space. They're not evil, they're necessary. And if you have a right IPR framework, they become a protection for everyone in the space. The way it works, though, or at least at Khronos, I think most standards organizations, the standards organization typically doesn't develop or patent technology. It's all of the participants, the members, or whatever participation model you have. They are the ones that have technology, and hopefully are patenting good stuff. Just that the IPR framework, and the Khronos IPR framework, like many others, it is essentially if you help build a standard, you agree not to assert your patents against anyone who implements that standard you've helped create, if they implement it in good faith. That's the agreement you need to get out of everyone who is participating at the appropriate point. And there are many examples of patent frameworks out there. Most of them are public. I can send the Khronos one if that's an interesting data point.
Yeah, I think that'd be good for. It's a bit maybe too much detail for the meeting, but
right.
It'd be good to read up on it.
So again, hopefully that was useful content.
Yeah, that was very, very useful. I feel like a lot of us aren't familiar with all the workings of standards bodies and governance. So thanks. Does anyone else want to share Peter?
I'm still trying to think in my head why the AGI Foundation comes second, and if it's okay, if I find it reasonable in sort of the hierarchy of, or the order of operations that Neil just presented. So the way that I see it at the moment is that at least from my corner of the AGI Foundation, the Neuromorphic Working Group part, it's also bringing together all of the other neuromorphic initiatives like Phasor together at the same table to discuss the first topic that Neil covered, which is the collaborative research and just discussions about at least what all of the other groups are trying to do, what are their problem spaces that they're focusing on, and whether there's something in common that we could all be doing. So the Phasor is one project. Neil, on your slide, you also had Fraunhofer. They're also trying to create an organization. I forget exactly what it's called now. Also for neuromorphic, for education, for not quite standardization, but at least for the education part, and to collaborate on some projects. In the US, there's also the Tor consortium. In Europe, there's additionally the eBrains spin-off from what used to be the Human Brain Project. There's bubbles, there are silos all over the place. My feeling is that this is also a risk to, I don't know, for all of us to just once again, instead of being siloed within our own academic institutions or within their own companies, you get siloed within these communities and then never talk. So I think that's at least what we're trying to do at the AGI Foundation, and the rest of the org is, I think, a good model to see how to actually build applications that are product ready. How do people build TinyML applications? And from my perspective, instead of starting with the very large problems, how do you train for a data center scale? Or how do you scale the communications for a data center scale? To starting with the smallest of problems first and figuring out what we're doing as a community on small problems, and then building up makes most sense. On the governance side, yeah, like I'm hoping VJ joins soon, because him and his students at Harvard have been doing a lot of work on benchmarking. So Neurobench is the first thing that we probably need to continue, V2 iteration, to get more contributions on the system tracks and on the algorithm tracks to see how we measure, not just within the neuromorphic community, but especially outside of it. How do we measure against traditional approaches, full system scale? Yeah, I didn't come very prepared with my thoughts, so I need to see more inputs and what I should be responding to.
Yeah, I think the other thing is that different corners of the community are at different stages. A lot of it is very research focused, but a lot of it is coming out of research now, which is where all these startups are coming from, especially focusing on very low power edge inference. There's so many applications they can support now. But at the same time, there's still so much potential, untapped potential. I feel like, enabling more potentially biologically inspired algorithms, but also in enabling more sparsity and things like that. And I think there's a huge pipeline that we can build here if we set things up properly, and help direct the research towards things that can become production. And that's one of the things I was hoping with the joint fund, was that we could fund research in a way that industry helps gravitate things that can enter production more likely. But yeah, I guess the other question is like, where's the money going to come from?
So I've also proposed this internally for the AGI Foundation. So I don't work for the AGI Foundation, but I've proposed that we also create some sort of fund there to help, at least for some of the projects that we'd like to keep alive, to be able to make sure that there's more effort, more people, more direction in that, and to provide some sort of funding. So we are also exploring that side. I think that but more importantly, the buy-in from a lot of different groups is maybe a bit missing for neuromorphics. Anecdotally, I heard that someone made a comment at the most recent neuromorphic conference in Heidelberg in Germany, that hey, what if instead of everyone still being, all of the research groups being super fragmented, creating their own software stacks, creating their own hardware implementations. How about if we rally around some of the available open source tools and companies trying to productize this? And as far as I understand, the response was a somewhat lukewarm, not that much interest in that perspective. So I don't think that, yeah, without the broad community consensus, we're still going to be a bit siloed, is my feeling.
Yeah, when I talked to David Cantor several months ago, he was, and I was still at Intel, he was saying, like, you should try to get Intel to commit $1 million to building the compiler and supporting a joint fund. But I talked to my manager, and that was, given Intel's situation, it was out of the question. And I don't know, it sounded like Synsense wouldn't have that much money to put in here. There were some university professors who mentioned that there's programs they could tap into, but it didn't seem like it'd be all that much. How does funding work at these other organizations? Is it mostly volunteer? Are there examples of research funding, joint research funds in these areas?
It was interesting. I think that the model changes. I mean, I was looking at these various organizations, and Petruț, please don't take this, because Edge AI Foundation was second on the list. Don't take that as a negative. It was all good. Everyone is doing fantastic work. I was just trying to put things in logical order to set a kind of framework on what the group should be thinking about. That's all. But I think the earlier groups, like Unitary Foundation, that they tend to be more on sponsorship and contributions, maybe from larger companies, like you say, Brian. Towards the back end, it tends to be a little bit more membership based. Khronos is entirely membership based, for example. So it does depend. There seems to be maybe some correlation. If you're doing kind of regular standardization work, everyone wants to share the load. Whereas if it's early stage, you're probably going to get some champions that are willing to sponsor. But there's no rule. I mean, the art of herding cats like this is you don't have a stick, you have to use a carrot, right? You have to use the carrots because you don't have authority over anyone. But welcome to my world. But so you have to identify why people would want to work together. What's the benefit? You have to be benefit focused. If you can identify the benefit to at least a critical mass of participants in this community, and clear benefits through cooperation, that's the starting point for building a coalition. And I can sense there's a good start here, but if you're looking for funding and stuff, I think that's really the bottom line. Why should I? That's going to be the question that comes up at every company and organization. And what do I get out of it? I might be all into cooperation and standards and open source, but if I don't get a benefit in the end, why should my organization engage? So
yeah, I've been trying to figure that out. My approach to this is trying to sell the story of, like, IBM held the Neuromorphic torch, like the big company torch, a while back. Then Intel held it for a while, but now it's already been almost 2 years since I think they've had a call for funding. And I think there's a huge space right now for another big company if they wanted to hold that torch. I'm trying to sell that story to AMD right now, but we'll see if they bite. I don't know if anybody else would be willing to do that. Google, ARM, someone else, but I'm hoping there's at least one hero company with deep pockets willing to help direct research in an efficient way, and NVIDIA maybe, where it can help the hardware vendors figure out what features to add in order to support these networks efficiently. Because in a lot of ways, we want to enable, if we can enable larger networks, train larger networks, even if it's not super efficient on conventional GPUs, CPUs, that can enable, these startups to have a larger market, start selling bigger chips at the edge, things like that. And I feel like there's a lot of synergy potentially if we set things up right.
Yeah, I don't disagree. But yeah, tangibilizing and crystallizing that benefit for immediate cooperation, even though the payoff may be a few years down the line, I think that's the key.
From the Edge AI Foundation perspective, and this is membership driven, because it's otherwise, apart from the neuromorphic part, a relatively mature organization. I mean, it's called Edge AI Foundation now, but it was called TinyML before, and it was clear what it was doing when it was called that, but now it's expanding a bit to look at small language models and stuff like that, but still very much a TinyML core remains in there. The benefit that I would see to the other members of the Edge AI Foundation is that they have, most of them, Sony, ST, Infineon, analog devices, Bosch, sensor and compute manufacturers have their own very small divisions, one or two people looking into neuromorphics, and they have their ear to the ground and they understand the promise. I think what they're looking for is to not miss out, so they're willing to put out a bit of money collectively instead of individually, as long as they get to see some very well done use cases on realistic data where they can see the performance numbers and they can get an idea of how these applications can work between different devices, so that if there's a user, they're not stuck in or locked in on a single vendor. And a lot of them have very big concerns about how to develop algorithms, how to develop networks, how to train them, to deploy them. So getting a couple of examples out there of how this can be done, at least for these smaller scale applications, not data center, but I think that would convince some of the other vendors and users that this is real and might invest a bit more effort and money.
Okay. Should we open it up? We have about 13 minutes left. Should we open it up to general questions from everybody? There's also 4 questions from the forum earlier. I'm reading through the questions that were submitted. I'm trying to see what we haven't already addressed.
I'm also looking perhaps a very practical question. I mean, are you looking to incorporate soon? And if you were, would you incorporate it as A in the US? And if so, would you do a C3 or a C6?
Well, I'm not sure if we would create like our own thing or just spread out to the different orgs
Yeah, sure.
that already exist.
Sure.
It would be up to folks here what they think makes the most sense. for me personally, I've just been trying to gather support and help set things up, because the job that I wanted in neuromorphics it didn't exist. And so I'm trying to make it exist. And so I feel like if a lot of these organizations are working on neuromorphics, that they all kind of legitimize each other, and I think makes it easier for additional companies to build teams. And so, yeah, I mean, it'd be up to I think the community what they want to do and the timeline they want to do it on.
Yeah, I mean, setting up an organization can give you independence and lets you have a particular focus, but it's also quite a lot of work to establish and manage an organization, even if it's relatively small to begin with. It can be quite a lot of bandwidth, which is maybe better spent actually focusing in on the technical questions. So maybe joining another group. I mean, the Unitary Foundation, it seems awesome, but it's very focused on its thing, which is quantum, which is not obviously it's different. Edge AI, does seem to be earlier stage and much more aligned. I mean, but Petra, I'm sorry, I don't know how to pronounce your first name. I hope I'm not mangling it too badly. My question about Edge AI is, it does seem to be aligned and in the right area. But neuromorphic computing is potentially more than just edge, right? So if this group were to go to Edge AI to start this cooperative work, I mean, how would you see that working out?
So yeah, I was thinking initially that it might make sense to not splinter off, but focus on the smaller problems first. And once the basic building blocks are there, that a wider community effort would be picked up anyway to see how it scales up to larger devices, to larger systems.
Mm-hmm.
The foundation has shifted from TinyML to Edge AI also because there's a focus on increasing the capabilities of the underlying systems. Everyone's edge is basically what is not the cloud, depending on your definition.
Mm-hmm.
So there's I feel a lot of space there until you reach the cloud. Heck, in my previous life, I used to work with at a university, at the University of Manchester, working on a 1 million ARM core machine to do brain simulations called Spinnaker. You get one of those smaller subsystems of that board, still 48 chips or so. Looks a bit like a Loihi, looks a bit like a spin cloud system. That could still be edge depending on your application. That could fit in a car, could fit in a train, could fit in a few different places. So I think at least the foundation of the work that's being done could be with the Edge AI Foundation. The basics could be with the Edge AI Foundation, to not reuse the same word. But it's likely not the only place. There's places like Tor that looking at larger scale that could pick up some of the slack at that end. So that's why the collaboration is necessary, at least that we all go in the same direction with an approach that is scalable. I don't think the Edge AI Foundation can fix everything or can cover the entire topic of Project Phasor.
Yeah, that's interesting. Thank you.
But I think at the very least, it would offer a nice structure and a lot of use cases and a lot of examples with all of the other working groups that it's also doing, like the datasets and benchmarking working group. How can the community provide better datasets or more production-ready datasets for TinyML or Edge AI type applications, which should also benefit neuromorphics. a lot of the applications now are just video/image based, but that's not at all, not necessarily compatible with what the neuromorphic promise is. So shifting the direction that datasets are, or what datasets are gathered and for what, is also something that we're busy doing.
Yeah, that sounds very interesting. Actually, I'm thinking Khronos and Edge AI should talk more. I'll reach out to you after. But
Please do.
But bringing it back to this group, I mean, yes, I mean, different groups helping you at different times would be good. I mean, again, I don't think Khronos is the right group right now. But eventually, once you get down into thinking, okay, now we have our neuromorphic IP blocks sorted out, how are we going to integrate with, you know, the rest of the more traditional accelerator blocks? You know, that would be the point where a group like Khronos would be delighted to help at that point. I think we could add value there, but I think it's some time before you get there, I think.
Brian, did you want to go through the questions in the chat?
So yeah, one of them was about data sets and potentially simulated worlds. Blessing, I don't know if you want to chime in. Oh, I cannot hear you.
Can you guys hear me now?
There we go.
Perfect. Hi. Hello, everyone. Sorry, I've been up and about. But back to dataset. The question was on datasets, right? So like I said in the initial presentation, for those that weren't here, we're more focused on building compilers, and I believe in the neural triangle, where we have the right dataset being fed to the right algorithm, being trained on the right hardware. So even if we fix the hardware, you know, we build the neuromorphic hardwares, how do we then figure out what kind of algorithms can be onboarded on said hardwares? And after we figure out what kind of algorithms can be onboarded on said hardwares, then what kind of data do we train on said algorithms? That's where I believe academia comes in, because for every research we do, we have to gather the data, clean the data, train the data. But in our case, we have a large percentage of RGB data, signal data moving up and down. And if we want to create like models that can benchmark already existing traditional models, we need event data, basically. Data that is spiking, that is brain-like, that can be fed on the spiking algorithm that can be trained on the, okay, Petruț, do you want to go? Do I continue? Do I want to go?
You can obviously finish your thought. I just wanted to raise my hand to say I have a thought about what you said.
Okay. So like I was saying, basically what we've been doing so far is using, like, you have different kind of simulators, like the Nego GUI, the brain simulators. You have the V2E simulator. Now, when it comes to converting data, you can either convert the already existing video data to event data, or you can actually use like an event camera to capture these data themselves and save it. And that's what I have been doing, V2E simulator. And if so currently right now we're working on trying to reach an action recognition benchmark in my lab for neuromorphic computing, for like fall detection and in fact image classification in general. But the issue, the problem is there are very few neuromorphic data sets that exist that we can actually use to reach the benchmark for already existing traditional models, because people are like, okay, we already have a fall detection system. Why would we want to use neuromorphic computing to create a fall detection system, right? And then you want to argue like, oh, if we use spiking hardware, if we use neuromorphic computing, you have low latency, low cost. And they're like, oh yeah, but how do you go about doing that? This event cameras are very expensive, right? So what do we have to do? Then we get this RGB data and then we convert it to spiking data. Now that conversion process is tedious on its own, but not impossible. It's doable. We're doing it. We're converting it. But then the issue is when other labs perform these tasks individually and there's no collaborative effort to have like a general warehouse or general pool of event data that can be used on neuromorphic algorithm that can be trained on neuromorphic hardware, we then cannot say, oh, neuromorphic computing performs better than already existing computing. Does that make sense? I'm going to stop yapping now and allow Pierre to go.
So my take on this is that instead of having spiking data sets or event data sets, that my perspective would be that it's better to get data that is neuromorphic friendly. Don't get images, but get video. Don't get spectrograms, but get record raw data and keep it as raw data, because all of the operations that you're doing on all of your data should count towards the total system budget and the energy expenditure. If you deploy an algorithm in the field next to a microphone or an RGB camera, any conversions that you do count, they matter for the battery that is attached to that device. And users, companies, sensor manufacturers, for example, who want to integrate some sort of intelligence in their system, they generally don't want to retrain their model. They want to be able to reuse the model that they have, or to have very limited impact on their workflow, the way that they've been doing stuff. So generally, the main issues that I feel exist with neuromorphics is that I've also tried to address a bit with Neurobench, is create a benchmarking environment in which traditional approaches could also compete. There's no reason why for the applications that we've selected for Neurobench, an MCU or an NPU couldn't take part. So we're doing neuromorphic benchmarking, but on datasets and use cases that are relevant to the industry, and is open for traditional von Neumann or whatever vector architectures, and where all of the conversions are taken into account. If you need to take the raw data and need to convert it to spikes or to other representations, then that is accounted for in the cost of the system. Otherwise, customers wouldn't have trust that they should replace their system with yours. Then the usage, how easy it is to use. It's actually super important for a lot of people to not need a PhD in neuromorphic computing to be able to program a neuromorphic system. And I think that eventually, hopefully with the sufficient education, or for a small shift in the way that we work within the neuromorphic community, we can get this understanding across and make the entire process easier, or as easy as grabbing a model off of Hugging Face and doing a bit of fine tuning and then deploying it to your favorite hardware. That needs to be super simple like that.
Okay, we passed the hour, but there's one question from Mohammed Aitsam. What could be the killer application that brings neuromorphic computing to the forefront of industrial adoption? I feel like some of that is already here, at least with like Gray Matter Labs. It seems like it's Sigma Delta networks. But what could that killer application be that might get, let's say, the bigger companies on board, like AMD, NVIDIA, get them to put in the money, seeing that this future might be near. From my perspective, it would be related to robotics or video. What really kicked my butt was when Sora came out, and I was like, how much compute do you need to do something like that? And it's continuous time. It seemed like it would be well suited for neuromorphics if we could do Gen AI stuff. But I get the sense that the neuromorphic community isn't so focused on Gen AI. I don't know.
So applications? That's the
applications, yeah.
What's the killer app?
What would be the killer application for neuromorphic hardware that increases industrial adoption?
I feel like I walked in on a conversation, joined in on a conversation in this call right at the beginning where I think it was, I don't remember who it was. I think it might have been Jack. Sorry, someone said at the beginning, we're here for mature technologies, not technologies looking for a problem. Am I misquoting? They might be misquoting, but.
So this is Jack. So what I said was, at some point we're working on kind of that hardware software. We can't come in and just say neuromorphic. What we wanted to do is kind of find the right place, kind of thing. So I can't, in the work group that we have, we just can't lead with the solution and say, okay, how do we start finding homes for it? What we really need to do is look at the ecosystem where some things fit, what workloads we have, what kinds of things we're going to go through. And if neuromorphic fits, now it fits and we actually find the right way to map it in.
Very much agreed. What is your definition of neuromorphic? Out of curiosity, not to put you on the spot, but.
Oh, so you can put me on the spot. I'm new to this whole space, so I'm kind of figuring it out. I do large scale distributed systems, so I'm learning, and I'll figure it out. But I'm hoping to learn from this group, and if this group defines something, then we'll definitely fit it in.
I'm only asking this because I know that we're doing a poor job at explaining what it is. And I know this from various conversations and asking so many people, what is neuromorphic to you? And everyone has a slightly different explanation of what that is.
It's a very ill-defined term.
I mean, in a sense, our approach to this is because we're not coming from the neuromorphic space, right? Like, we're not saying we want to build a neuromorphic system. We are much more a general hardware-focused group, and in that, don't bother too much with saying is something neuromorphic or not, right? So we consider obviously some in memory compute technologies, which then some people end up calling neuromorphic. But whether it's called neuromorphic or not isn't too much of relevance to us. Does it make sense? Like, we think about them more as like, how is the system set up? How does it fit into the system setup? And if it looks something like in memory compute would work, then that's great. Even if there was something like workload-wise, which looks like it could map well on like an analog system, sure, that's great. Like, in a sense, we don't mind too much. I guess the clearest definition of it is like, once you go into spiking network regime, I guess it becomes quite obvious it's neuromorphic, I guess. But it's more kind of on the algorithm level rather than the hardware level, right? So at least as long as you're in digital, that is. So it's a bit of a dodged answer, I guess, from me and Jack, as in like, for us, it's not too relevant what it's called, as long as the workload works.
I think this is a topic maybe for another day or another beer.
Like, one of the areas that I am most interested in enabling is the neuromorphic virtual machines for researchers to run their algorithms on, so that they're not so constrained by the hardware that is out there. Do folks have an opinion on, where something like that should exist? I feel like it would be nice to have one area where people are working together to collaborate, so that like you have a shared compiler that can target multiple virtual machines. But at the same time, I feel like this is something that multiple orgs could be doing, because there's so many dimensions to explore when you're doing hardware architecture search. And yeah, you can have a range of virtual machines, ones that are very easily hackable and understandable by the algorithms researchers. So it doesn't reflect hardware very accurately, but it's easier to understand and for researchers to hack on. And then you could go the other direction, where you're even doing gate level simulations. And I think like there's a broad range of virtual machines, digital twins, or whatever you want to call them, simulators that we could build that would really, I think, open up the search space. You know, we're getting Intel before, their hardware is very flexible, but still not as flexible as I think a lot of people wanted. And especially once you get to the edge accelerators, a lot of them are very fixed function and not that programmable. And so in some ways it's good to have those constraints, because then your research is a bit more guided, and the algorithms that you do come up that work with that hardware would be very efficient. But at the same time, I feel like there's space to open up those constraints a bit more. Do folks have an opinion on where something like that should exist?
Brian, could you please repeat the last question you had?
Oh, just, you know, if we had a library of virtual machines that people were working on collaboratively that could be reused by algorithms researchers, you know, how should that be organized? Should it exist in multiple orgs, or just something more informal? It'd be like an open source kind of thing, not an open standards. We could even have like
this is very much a question for some of the folk who've seen this before and have seen maybe this fragmentation and how this was brought together. So I don't know if Neil or Jack have any thoughts about this, because I would love to hear their thoughts.
Yeah, I think it does. It does speak to, because we don't have the killer use case quite identified yet, that a looser collaboration is needed. I mean, just using the 3D, you know, as one example, it really came to life when the killer use case became obvious. And in that case, it was games. Right? People wanted to do 3D games, and suddenly it all just gelled. Before then, you know, it was more nebulous, and if you need to get people together to figure out what maybe the killer use case is, or a killer use case that's interesting enough that people can see the clear path to money if they collaborate. And until then, you know, bringing together people to collaborate on tooling, you know, or investigating use cases like, you know, Edge AI does, is a good platform maybe to really get consensus around what that use case would be, or use cases.
Use case requirements or application requirements tend to shift rather slower than what the algorithm,
Yeah.
And the requirements that the algorithm imposes on hardware, time to catch up on the hardware side to support
Yeah.
CUDA, to support the NUDA, the neuromorphic version.
Yeah, figure out what to do and then figure out how to do it. That's probably the right order. And I think that's kind of what Jack was saying too. So.
But I do agree with Brian, you know, so if we do get virtual machines where people can kind of kick the tires, go through and provide kind of a library where we can collaborate. Also sets up the virtual machines are nice, or containers, whatever you decide to pick. Makes it a lot easier because now we have the software environment, things like that, and people can start at a common base versus reconstructing something. And I think to the point that was made, it also gives kind of the baseline of what the understanding was, what the requirements were, how it was met. And now we can actually exchange. So if there's another piece of hardware that we could map into to satisfy whatever the container is, it gives us a way to kind of build a kind of common dialogue and understanding where we can go back and forth. Even to your point, Peter, about ramping people up. You can now say, here's what I mean by this particular thing. And now they can see it in action because they actually have an example, even if it's a toy, just to get started.
Yeah, one thing I'm excited about with an organ like OCP starting to look at neuromorphics is getting people that are outside of the neuromorphic community looking at the problems that we have, and setting up ways for, you know, getting their expertise transferred over in ways that, you know, the algorithms researchers can really use. And I think the you know, digital twins or virtual machines, they'd be a really good way to incorporate that knowledge, that hardware knowledge, especially as we get into like the analog domain, where the math gets really really crazy. But you know, even in the digital domain, baking parameters in, like, once we start exploring 3D stacking of chips and memory hierarchies, how do we model the power of that kind of thing? Like a lot of the neuromorph companies right now are focused on very much SRAM based technologies, but you know, I feel like once we go to larger and larger models, the thing we see with LLMs today is you have like these really hot weights and really cold weights. And I think once we have large neuromorphic models, we have the same thing. And even though one of the things about neuromorphic is combining compute and memory, co-locating it, I feel like there's still a benefit to be had from a memory hierarchy. What would that look like when you're 3D stacking stuff? And yeah, can neuromorphics bring a benefit there? Are they so much lower power that you can stack even more than you could using conventional methods? Just trying to answer questions like that. I think we need the help from people at the forefront of the hardware and fabrication and all that.
Brian, if I could volunteer a slightly different perspective, mine is more in the direction of, if you could convince someone who's on the forefront of computing now, or inform them about some of the benefits / methodologies / paradigms within neuromorphic computing, to let them explore how those can fix some of their problems, that would, if feasible, if you could actually make them happen, that it would be beneficial for them. And then they would start looking at, can we adopt this? There's a problem with that. Maybe we can offer a solution to the problem to help themselves. At least that's my perspective.
Are you saying like it would enable hardware folks to explore things that would benefit neuromorphic algorithms more, like a two-way street?
Yes, I'm saying show what the benefits are and how one could reach those benefits. And then once someone on the other side who's not interested or doesn't care about the label of is it neuromorphic or not, that they can think in their own time, oh wow, that particular concept, this bit here or this bit here, the entire system helps me in whatever problem I'm currently having. I want to adopt this bit because this actually will solve my problem. Rather than focusing too much on the technology, whether it's an SNN or not, or whether the underlying hardware is an MCU, an accelerator, SRAM based, not SRAM based. Those we can figure out later. Those are just engineering problems.
Okay. Yeah, blessing.
So if I get Petruț very clearly, it's looking more towards the application standpoint of neuromorphic computing than the engineering standpoint of neuromorphic computing, right?
I think what I'm trying to say is, instead of thinking that someone will come in, a user group will come in and fix our problem, in the neuromorphic field. I think it's more reasonable to have a dialogue, to present what the benefits are in a realistic sense, with sufficient clarity and just sufficient intuition to someone. Why would you choose this approach?
Okay.
Here are the power numbers. Here's the technique. Here's the strategy. Here's how you do it. Super easy, not exotic at all, super friendly. And that would get more people thinking, I need this bit here of what was described because it solves a particular problem, a use case, something.
Okay.
So yeah, application focus is one, I guess.
Okay.
Hardware is also very much important. The field is large. There's large. It's there's quite a few people in the neuromorphic domain. I think everyone pulling in the same-ish direction with their individual expertise and focus, either on hardware or on algorithms, or a mix. But as long as we're going in the right direction with the right goals, is my perspective.
Yeah, I think we touched on all the questions that were submitted. It seems like a lot of people dropped off. We went way over. Thanks for staying, everybody.
There's a new question.
Huh?
There's a new question.
A new.
Here.
Oh, in the chat or?
Yeah, in the chat.
We've been very busy in the chat.
I saw it scrolling by. But I think that'll be captured in the.
Yeah, cut and paste that before you quit the call. Hey,
Yeah.
I have to drop to my next call, but this is also Ryan. Let me know. Hopefully this was helpful. Let me know if I can help. Happy to stay engaged if it's helpful.
Definitely. Thank you. Thanks, everybody. I think we'll just call it here, unless anything.
Take care. No, sounds good.
All right.
Take care.
Thanks, everybody.
See you. Bye.